A Brief History of Time is a popular science book published by British physicist Stephen Hawking in 1988. The book covers the fields of cosmology, relativity, and quantum mechanics, and aims to introduce the public to the development of modern physics and its major findings. A Brief History of Time is divided into 11 chapters, including an introduction, the birth of time and space, the expanding universe, the changing universe, the tiny structure of the universe, black holes, the arrow of time, quantum mechanics, unified theory, conclusion, and the image of our universe. In the book, Hawking introduces in easy-to-understand language the important theories and discoveries of modern physics, including the Big Bang theory, the black hole theory, the arrow of time theory, quantum mechanics, string theory, etc., while incorporating his own thoughts and perspectives on these theories. In addition, the book also explores the origin, development, and end of the universe, as well as the historical development of human observation and understanding of the universe. In addition, Hawking also discusses some philosophical questions, such as whether God exists, whether the universe has an ultimate goal, and so on, allowing readers to think more deeply about the existence and nature of the universe. A Brief History of Time is a comprehensive work that integrates science, philosophy, history, and other disciplines, and is regarded as an encyclopedia of modern physics with great popularity and influence. It has not only contributed to the promotion of knowledge and ideas of modern physics, but also inspired many people to think about and explore the universe and human existence. A Brief History of Time, The Birth of Time and Space focuses on the origin and evolution of the universe, which is also the area of study in modern cosmology. According to Hawking, the origin of the universe can be traced back to the Big Bang about 13.8 billion years ago, when the entire universe was in a state of very high temperature and density, and a tiny point instantly expanded into a huge space. Hawking explained how time and space were born simultaneously in the Big Bang. He proposed a generalized relativistic view that time and space are interrelated and mutually influenced, called space-time. At the time of the Big Bang, space-time was bent and deformed by the extremely high energy, which makes it necessary to use the tools of general relativity and quantum mechanics to understand the origin and evolution of the universe. In the following chapters, Hawking explores the evolution of the universe, including cosmic expansion and cosmic background radiation. He introduces the discovery and significance of the cosmic microwave background radiation, which is one of the most important pieces of evidence for understanding the early evolution of the universe due to the residual radiation produced after the Big Bang. In addition, Hawking raises some philosophical questions about the origin of the universe, such as why does the universe exist? And did the universe need a god to originate? He argues that these questions may not be within the realm of science, but science can provide valuable ways to think about and explore them. Chapter 2 of A Brief History of Time presents the basic concepts and knowledge of the origin and evolution of the universe, while also addressing some philosophical questions that provide the reader with a deeper consideration of the universe and human existence. A Brief History of Time, The Expanding Universe, explores such topics as the expansion of the universe and dark energy. Hawking introduces the concept of the expanding universe and the theoretical underpinnings behind it, including Hubble's law and the redshift of the universe. He explains how the rate of expansion of the universe has changed over different historical periods and the implications of these changes for the evolution of the universe. At the same time, Hawking also explained the basic components of the universe, including ordinary matter, and dark energy. Among them, dark energy is a force that is widespread in the universe and acts on the expansion of the universe, and is also one of the most mysterious substances at present. Hawking describes the history of the discovery and study of dark energy, and discusses its possible nature and effects. Finally, Hawking also introduces the concept of cosmic background radiation and its important role in the expansion of the universe. Cosmic background radiation is the residual radiation from the Big Bang, characterized by a spectrum that is constantly shifting during the expansion of the universe, and provides a powerful tool for exploring the evolutionary history of the universe. Through this presentation, we can gain a deeper understanding of the concepts of cosmic expansion and dark energy, and their important role in the evolution of the universe. At the same time, Hawking provides readers with a way and means to delve deeper into the evolution of the universe. A Brief History of Time, The Changing Universe explores some of the key issues in the evolution of the universe and cosmology. Hawking begins by describing the history of the evolution of the universe, starting with the Big Bang, through the formation of the cosmic background radiation, atomic nucleosynthesis, and the restructuring of the universe to the universe as we see it. Next, Hawking explores the future evolution of the universe. He believes that the future of the universe will depend on the density of the universe and the rate of expansion of the universe. If the density of the universe is large enough, then the universe will eventually stop expanding and begin to collapse into a state of great collapse. If the density of the universe is small enough, then the universe will keep expanding and spreading and will never stop. In addition, Hawking discusses the concepts of black holes and time travel. He introduced the formation and evolution of black holes, as well as the nature and behavior of black holes. For time travel, Hawking presents some interesting ideas, including the closed time curve and the time travel paradox. Through this presentation, we can gain a deeper understanding of the evolution of the universe and some important questions in cosmology. At the same time, Hawking also provides readers with the means and methods to explore these questions in depth. A Brief History of Time, The Tiny Structure of the Universe explores the microscopic structure of the universe and elementary particle physics. Hawking first introduces the concept and classification of elementary particles, including quarks and leptons. He then discusses the interaction of elementary particles and the workings of particle gas pedals, as well as the importance of elementary particle physics to cosmology. Then, Hawking introduces quantum mechanics and relativity theory and discusses the shortcomings of these two theories. He proposes some new theories and hypotheses, including superstring theory and M-theory, and discusses the strengths and weaknesses of these theories and their future directions. Finally, Hawking discusses some concepts and problems of cosmology, including cosmological constants, dark matter, dark energy, etc. He introduces the origins of these concepts, their origin, and their future development. He describes the origins, progress, and current status of these concepts, and discusses their implications for the evolution and structure of the universe. Through this presentation, readers can learn about the basics of elementary particle physics and the progress of research, as well as their importance to cosmology. At the same time, Hawking introduces new theories and hypotheses that provide readers with the means and methods to gain a deeper understanding of these issues. A Brief History of Time, Black Holes explores the concept, formation, and nature of black holes and their implications for cosmology. Hawking first introduces the definition and classification of black holes, including parameters such as mass, spin, and charge, and their effects on black holes. He then discusses the process of black hole formation, including stellar evolution and supernova explosions. He introduces the gravitational effect and event horizon of black holes, and discusses the singularity problem of black holes and their quantum effects. Next, Hawking explores the cosmological implications of black holes, including their role in cosmological evolution and their impact on the formation and evolution of galaxies and the structure of the universe. He also discusses the connections and relationships between black holes and cosmological concepts such as dark matter and dark energy. Finally, Hawking introduces some new theories and hypotheses about black holes, including the black hole information loss problem and rebound cosmology, as well as the total experimental verification and future directions of these theories. Through the presentation, readers can understand the basic concept, formation, and nature of black holes, as well as their role and impact in cosmology. At the same time, Hawking also introduces some new theories and hypotheses, providing readers with a deeper understanding of black holes and their cosmological implications and methods. A Brief History of Time, The Arrows of Time explores the nature, direction, and arrows of time. Hawking first introduces the concept and measurement of time, and the concept of space-time and relativity. He then introduces entropy in thermodynamics and the second law of thermodynamics, and discusses the concept of the arrow of time and the problem of time symmetry in physics. Then, Hawking discussed the existence and direction of the time arrow, including the time arrow in cosmology, the time arrow in thermodynamics, and the time arrow in psychology. He also introduces the implications of the time arrow for cosmological evolution and cosmological origin theories, as well as thoughts on time travel and the future of humanity. Finally, Hawking discusses the philosophical significance of the time arrow and its reflection in human culture, including the concept of time and the question of time in philosophy. Through the presentation, readers can understand the nature, direction, and concept of the arrow of time, as well as its influence and reflection in physics, cosmology, psychology, and philosophy. At the same time, Hawking provides some reflections and explorations on time, offering readers a way and means to gain a deeper understanding of time and its philosophical implications. A Brief History of Time, Quantum Mechanics explores the concepts and applications of quantum mechanics. Hawking first introduces the basic theories of force, electromagnetism, and thermodynamics in classical physics, and then introduces the basic concepts of wave-particle duality, the uncertainty principle, and quantum entanglement in quantum mechanics. He then introduces the applications of quantum mechanics, including atomic physics, quantum field theory, quantum electrodynamics, and quantum gravity theory. He also discusses the concepts and applications of quantum computers and gives an outlook on the unification of quantum mechanics and relativity. Finally, Hawking discusses the philosophical implications of quantum mechanics and its impact on the human worldview, including its challenges and insights into physics, science, philosophy, and human culture. A Brief History of Time, A Unified Theory explores the dream of physicists to pursue a unified theory that explains all fundamental physical mechanics phenomena. Hawking describes the development and evolution of various theories, such as general relativity, quantum mechanics, and elementary particle physics. Then, Hawking introduces one of his own theories, namely quantum gravity. Quantum gravity is a theory that attempts to combine quantum mechanics and general relativity. In the book, Hawking briefly introduces the main ideas of this theory and discusses some of its possible consequences. He also discusses the thoughts and explorations of many other physicists on the subject, such as fundamental string theory, supersymmetry theory, and grand unification theory. Finally, Hawking discusses the importance and challenges of the human quest for a unified theory, and presents some fundamental questions that he believes should be addressed. He also looks at the future development of physics and possible directions. Through A Brief History of Time, readers can learn about the quest and efforts of physicists to find a unified theory, as well as some of the theories that have been developed so far. At the same time, Hawking provides a way and means to gain a deeper understanding of these theories and their philosophical implications. A Brief History of Time, Images of Our Universe, is a chapter on the historical development of human observation and understanding of the universe. Beginning with Aristotle, Hawking presents a step-by-step account of the development of human understanding of the universe, including contributions from physicists such as Ptolemy, Copernicus, Brahe, Kepler, Galileo, Newton, and Einstein. In this chapter, Hawking introduces some basic concepts about the universe, such as galaxies, stars, planets, and black holes, and explains how they interact with each other. He also introduces the evolutionary history of the universe, including the Big Bang theory and the concept of dark matter. In this chapter, Hawking also introduces the concept of cosmic background radiation and explains how it provides information about the evolutionary history of the universe. He also discusses the topology and shape of the universe, and presents some speculations and theories about the structure of the universe. Finally, Hawking discusses the possibilities for future exploration and development of the universe, and presents some ideas and scenarios for future exploration of the universe. Through this presentation, readers can learn about the development of human knowledge of the universe and some basic concepts, as well as explanations and theories of phenomena such as the evolution of the universe and background radiation. At the same time, Hawking provides a deeper understanding of the structure and evolutionary history of the universe. The concluding section of A Brief History of Time summarizes the main contents and ideas of the book and presents Hawking's views on some important issues. In this chapter, Mr. Hawking reviews the development of physics and the evolution of theory, and discusses the origin, structure, and fate of the universe. He points out that the achievements of modern physics and cosmology have led to a deeper understanding of nature and the universe, but have also raised many unanswered questions and challenges. Then, Mr. Hawking raised the question of whether mankind could find the ultimate theory. He argued that although there have been many important achievements in physics and cosmology, there are still many unanswered questions and contradictions, and therefore we may never find the ultimate theory. However, he also said that this does not mean that we should stop exploring and pursuing the truth, rather, we should continue to work hard and keep expanding our knowledge and vision in order to better understand nature and the universe. In addition, Mr. Hawking also raised the question of whether there is a God. He believes that science has confirmed the origin and evolution of the universe, and that these processes can be explained as the operation of natural laws without the intervention of God. Therefore, he argues that there is no one specific God, but the existence of some form of religion or supernatural force cannot be ruled out either. In conclusion, the concluding section of A Brief History of Time offers many insightful and illuminating perspectives and observations through the exploration of issues in physics, cosmology, and philosophy. These views and opinions are not only important inspirations and influences for the academic community, but also provide a lot of inspirations and thoughts for the general readership. Through reading and exploring important books such as A Brief History of Time, we should continue to expand our knowledge and vision in order to better understand the world and ourselves. In addition, in his closing remarks, Mr. Hawking also mentioned the impact of the development of science and technology on human society and civilization. He pointed out that the development of science and technology has brought many significant advances and benefits to mankind, but also brought many new problems and challenges, such as environmental problems, energy problems, artificial intelligence, and so on. He called on us to respond to these challenges and take positive actions to maintain and promote the sustainable development of human society. Finally, in his closing remarks, Mr. Hawking also expressed his confidence and hope in science and human civilization. He believes that science and human civilization will continue to develop and advance, and bring a better future to mankind. His words are full of positive energy and hope, inspiring readers to keep moving forward and exploring. All in all, A Brief History of Time is a book of great value and depth, providing readers with much inspiration and reflection through its exploration of physics, cosmology, philosophy, and many other fields. Through my introduction and recommendation, I can attract more people to pay attention to and read this book, so that we can continuously expand our knowledge and vision and explore a broader and more profound world.